Low-Frequency RFID Reader IC by Atmel. Welcome to the training module on low-frequency RFID reader ICs. This training module introduces basic knowledge of RFID technology and the U2270B low-frequency RFID reader IC. Radio frequency identification, or RFID, involves contactless reading and writing of data into an RFID tag's non-volatile memory through an RF signal. An RFID system consists basically of two components, a transponder and a reader. The transponder includes the IC, and in low-frequency or LF systems, optionally a capacitor and a coil. High-frequency systems only need a coil. UHF systems, an antenna. The reader generates an RF field, which is used to transmit power and to perform bidirectional contactless data transmission. The reader emits an RF signal, and data is exchanged when the tag comes in proximity to the reader's signal. The reader decodes this data, sends it to a host, or displays it. The RFID tag derives its power from RF reader signal and does not require a battery or external power source. RFID is becoming increasingly prevalent as the price of the technology decreases. RFID systems guarantee reliability even in dirty and harsh environments. Efficient and time-saving systems can be achieved by fast and secure identification solutions that do not need direct contact or line of sight. Accurate manufacturing and logistics systems enable us to save time and money using RFID technology. Convenience and time efficiency are the reasons why RFID is used in the transportation segment. In addition, RFID is significantly involved in the improvement of livestock tracking. Stock monitoring, breeding, or disease control are also supported. To control access to buildings or other objects by persons or items, RFID systems ensure absolute security. In addition to identification, an RFID card may be used to store value. Whether as a transportation pass, loyalty card, an electronic purse for food purchase or parking, RFID provides convenience and security. There is no global public body that governs the frequencies used for RFID. RFID systems currently operate in the low-frequency, high-frequency, and ultra-frequency bands. Low-frequency and high-frequency can be used globally without a license. Ultra-high frequency cannot be used globally as there is no single global standard. Each frequency has advantages and disadvantages relative to its capabilities. It is generally safe to assume that a higher frequency equates to a faster data transfer rate and longer read ranges, but also more sensitivity to environmental factors such as liquid and metal that can interfere with radio waves. Correspondingly, a lower frequency means a lower read range and slower data rate, but increased capabilities for reading near or non-metal or liquid surfaces. The reader IC U2270B operates as a bidirectional interface between the transponder and the microcontroller. It amplifies the transponder signal and provides the signal to the microcontroller for decoding. The input characteristics of the U2270B are suitable for Manchester and biphase modulated transponders with data rates between 2 and 5 kilobaud at 125 or 134 kHz operating frequency. The reader system based on the U2270B supplies the energy for transponders via the magnetic field. The IC fully supports Atmel's write method, which requires switching the field on and off within certain time intervals. The IC incorporates the energy transfer circuit to supply the transponder. It consists of an on-chip power supply, an oscillator, and a coil driver optimized for automotive-specific distances. It also includes all signal processing circuits which are necessary to transform the small input signal into a microcontroller-compatible signal. The 12-volt supply capability is achieved via the on-chip power supply, which provides two different output voltages, Vs and V sub ext. The fully integrated low-pass filter removes the remaining carrier signal and high-frequency disturbances from demodulation. The driver supplies the antenna coil with the appropriate energy. The U2270B has 3 operation modes to power the IC: 1-rail operation, 2-rail operation, and battery voltage operation. In 1-rail operation, all internal circuits are operated from one 5-volt power rail. V sub S, V sub EXT, and D sub VS serve as inputs. VBAT is not used but should also be connected to the supply rail. In 2-rail operation, the driver voltage D sub VS and the pre-driver supply V sub EXT are operated at a higher voltage than the rest of the circuitry to obtain a higher driver output swing and thus a higher magnetic field. V sub S is connected to a 5-volt supply. This operation mode is intended to be used in situations where an extended communication distance is required. Using battery voltage mode, V sub S and V sub EXT are generated by the internal power supply. An external voltage regulator is not needed. V sub EXT supplies the base of an external NPN transistor and external circuits. The driver supplies the antenna coil with appropriate energy. The circuit consists of 2 independent output stages. These output stages can be operated in 2 different modes. In common mode, the outputs of the stages are in phase. In this mode, the outputs can be interconnected to achieve a higher current output capability. Using the differential mode, the output voltages are in anti-phase, thus the antenna coil is driven with a higher voltage. For a specific magnetic field, the antenna coil impedance is higher for the differential mode. As a higher coil impedance results in better system sensitivity, the differential mode should be preferred. The MS pin is used in mode selection. This application uses few external components. It is for intense magnetic coupling only. This application uses diode feedback. It allows higher communication distances than application circuit 1 presented in the last slide. This application is comparable to application circuit 2, shown in the last slide, but alters the operating frequency. This allows higher antenna resonance tolerances and/or higher communication distances. This application is preferred if the detecting microcontroller is close to the U2270B, as an additional microcontroller signal controls the adequate operating frequencies.